So IPv6 routing technologies, changes to the address architecture have introduced the need for routing protocols that are capable of supporting IPv6. IPv6 routing protocols include what we call OSPF version 3. The characteristic and operation of each of the OSPFv3 generally reflects those used in OSPF version 2. So they're not very different. However, they contain some distinct differences that are required to be understood to support the implementation of IPv6 based routing protocols within an IPv6 founded network. By the end of this chapter, you should be able to, a volunteer,
describe the characteristics and operation of OSPF version 3, configure OSPF version 3 routing protocol for IPv6.
Thank you very much, Dixon Dego. Please now mute your mics so that we can look into this. Now, please mute your mic. Valerie, mute your mic. Okay. So, OSPF version 3 is the OSPF version that supports IPv6 networks. So when you're using IPv6 addresses for your interfaces, so that interface has been assigned an IPv6 address. The loopback interface here have been assigned a global unique IPv6 address. See, when you're using IPv6 addresses, we can only use OSPF version 3. You cannot use OSPF version 2. OSPF version 3 updates are sent to all OSPF routers address using this multicast address, which we've already looked at in the previous chapter. So when you are sending your LSAs, the destination will be FF02:5. So every router that receives this packet is going to process it. Then link local addressing is used by default to define the next hop. So this particular IP address here, so the next hop is the next router to which we are going to pass, the next interface that we are going to pass a packet towards its destination. So the next hop. So if we were to pass a packet to RTA, so we must specify this interface address, which is this IPv6 address. So that's the link local next hop. This particular IPv6 address is not very different from the one that is used in IPv4. Remember, in IPv4, for the all routers multicast address, we use 224.0.0.5. So they almost look similar because they all end with 5. So for all routers, they listen for OSPF packets on FF02:5. In OSPF version 2, they listen on 224.0.0.5. It should be noted that you cannot be able to run both versions in the same network because they are not compatible. They are not. So OSPF version 3 and OSPF version 2 are not compatible. Just like in OSPF version 2, in OSPF version 3, routers are uniquely defined using the router ID. So you can see here, right? RTA as a router ID, of 111, 222, 333, and 444. So every router in OSPFv3 network must have a router ID. Now, if you can remember, in OSPF version 2, there was a syntax, actually, let me call it a syntax. So we had a syntax for coming up with a router ID. Can someone remember some of the processes? Well, the very first one was manually configured. So manually configured router ID. The next one, if a router does not have a manually configured router ID, what happens? What does the router go for? Yes, Brian?
The IP address of the loopback interface, the highest.
Exactly.
Highest
configured loopback address. Remember, this is an IPv4 address. Then, if that is not there,
the highest IP address of an interface, an active interface.
Physical interface address. Again, this is an IPv4. Now, reason as to why we could be able to pick an IPv4 address from a physical interface or a loopback interface is because the router ID has the same architecture as an IPv4 address. Both of them are made up of 32 bits and are written in the dotted decimal format. However, that is not possible in OSPF version 3 because IPv6 have completely different architecture made up of 128 bits. So in IPv6, we can only configure router IDs manually. By the way, why do we need router IDs? What are they used for? Someone? In OSPF, why do we need router IDs? Yes, Dixon?
Well, they'll be useful when we are electing a DR and BDR.
So it can be used during the election. So when the router priorities cannot be used to break the tie, then we look at the router ID. Which router ID is preferred? The highest or the smallest?
The highest.
The highest. Thank you very much. So for election, what else is the router ID used for? Someone raised their hand. Just go on and talk.
Yeah, I think the other reason as to why we need the router ID is to determine that router's responsibility in the network, because we understand that routers that have an ID of 000 cannot participate in electing the DR and the BDR.
No, not really, Henry.
I think it is to uniquely identify a router in an OSPF area.
Exactly. To uniquely identify a router in an and in extension, really to identify neighbors. To identify neighbors. That's why you can type display OSPF neighbors. Then you can be able to see that you're a neighbor with 1.1.1, 2.2.2. So identify the neighbors, to uniquely identify routers in an area, in an OSPF area. So Henry, what you're confusing is the router ID and the priority, because the router priority, when configured as 0, then that router's interface is not going to participate in the election. for a DR or a BDR. So that's the priority, but the router ID is different. But priority is used for election. Router with the highest priority becomes the DR. Second highest becomes the BDR. So just like in OSPF version 2, in OSPF version 3, we also have elections in broadcast networks and in the NBMA networks. Henry, did you lift up your hand?
Yeah, just
Yes.
a clarification of some facts, because
Please
yesterday in our morning class it was mentioned. Can it ever occur a situation whereby the router ID is 0.0.0.0? And what does that mean? Because in our yesterday's class it was implicated to be a router. That is a bit different from the priority.
Router ID?
Yeah.
Yeah.
In our yesterday's class in the morning, it was explained that if a router has that ID of 0.0. The four zeros, then that means that router cannot participate in such an activity. That is in election of the DR and the BDR.
To be honest, I haven't seen a router ID of 0.0.0. Maybe during the break you can research. Then at the beginning of the next lesson you can let us know. I'll also try and do my research, but I haven't seen a router ID of 0.0.0. So just check. Then you can let us know in the at the beginning of the next lesson. We are going for a break after this, so you can tell us now. In order to communicate to the DR and the BDR, you have to use this multicast address F02 /6, which is also almost similar to the IPv4 multicast address that DR and BDR listens on 224.0.0.6 for all DR routers. So the DR and the BDR will always listen for updates, OSPF version 3 updates on this particular address FF02 /6. So OSPF uses what we call the per link behavior rather than per subnet behavior. OSPF version 2 uses per subnet behavior. That is, in OSPF version 2, OSPF processes are only able to communicate if you're within the same network or subnetwork. That means that your network bits are the same. On the other hand, with OSPF version 3, it's actually per link, and when you talk of a link, we're talking of a medium. So if you're connected over the same medium, then even though you might be on different networks, you can tell by the network bits. Even though you might be on different networks, you'll still be able to communicate within the link. So that is what we call the per link behavior, and this actually affects how the LSAs are shared. So remember that in OSPFv3, packets are shared per link and not really per subnet. The other thing that was removed in OSPF version 3 is authentication. So in OSPF version 2, we had the authentication type field, and also the authentication value field. So in OSPF version 3, we do not have authentication. So of course, authentication is left for the IPv6, and it normally relies on the IPv6 extension headers, in particular, the authentication header, and also the encapsulating security payload header, ESP. So we don't have authentication. So when you'll be configuring OSPF version 3, you're not going to configure authentication anyway. So let's see, how do we enable OSPF version 3? So here we are in RTA. So we need to start by enabling IPv6 under system view, and then we type OSPFv3 and the process ID. If we don't type the process ID, eventually it will pick up process 1. Then remember, we need to manually configure. We must manually configure the router ID using the command router-id space, then 1.1.1. Then after that, we need to enable IPv6 on the interface. So here we are enabling IPv6 on this interface G/0/0. Then we configure an IPv6 link local address. So here we are using this link local address FE80 full double colon 1. So you say when you're configuring an address, you can use the condensed format. You don't have to type the full IPv6 address. Then you need to enable that OSPF process on that interface. So here we are enabling OSPFv3 process 1, and we are also adding that particular interface to area 0. So you know that you can create different areas. And I think maybe this is what Henry is confusing. This is not a priority, this is an area. So here when we say area 0.0.0, so it means that this interface belongs to area 0. You can create multiple areas, area 0, area 1, area 2, but the very first area you create should always be area 0, because all the other areas are supposed to communicate via area 0. So in order to be able to expand much later, you need to use area 0. Area 0, so that is area 0. If you do HCIP, again, you're going to learn more and more about OSPF and other routing protocols such as ISIS. So we're also doing the same on the loopback interface. So we're simply creating a loopback interface, loopback 0. We enable IPv6. We assign it a globally unique IPv6 address. Then we enable OSPFv3 process 1, and we also add it to area 0. So that is what we've done there on RTA. So we are supposed to do the same on RTB. So after that, we can use the display command, so we can see, and we can see that this is OSPFv3 on process 1. The router ID is 1.1.1, and we can see some other information. For example, the number of full neighbors is 1. So those are some of the details you can see. Okay, so that is it about this topic. So can someone please help us in reading and answering this question? A volunteer, please. Yes, Kennedy.
What is used to uniquely identify each neighboring node running OSPF version 3? The router ID.
The router ID. The router ID. Thank you very much, ladies and gentlemen. That is it for this chapter.